Consider f of x, g of x, and h of x. So f of x is equal to the square root of x, g of x is equal to x squared plus 1, and h of x is equal to 2x. Etong mga klase ng function na to, madali lang kunin yung kanilang integral kasi meron tayong formulas to do that. However, if we take the integral of 2x times the square root of x squared plus 1 dx, this is a different story. Notice that the integral expression is a combination of the functions f, g, and h. Particularly, ito yung h of x natin. Tapos, etong part na to is actually a composition of f of x and g of x. So, this is now h of x, and this is f circle g of x. Now, paano natin kukunin yung integral kapag ganito na yung ating function? This leads us to our first theorem, the chain rule for differentiation. It states that if g is differentiable at x and f is differentiable at g of x, then the composite function, capital F, is equal to f circle g, defined by capital F of x equals f of g of x, is differentiable at x, and capital F prime is defined by capital F prime of x is equal to f prime of g of x times g prime of x. So let's take this example. Let h of x be equal to the square root of x squared plus 1. Let's find the derivative of h. So for our solution, observe that yung h of x natin is actually a composition of function. Yung f of x natin ay square root of x. Tapos yung g of x natin is x squared plus 1. So parang ito, pinasok natin doon sa f of x natin. Now, taking the derivative of f and g, so f prime of x now is equal to, diba, this is equal to x raised to 1 half. So that is 1 half times x raised to negative 1 half. Tapos ito naman, 2x lang yan. So that is f prime of x is equal to 1 over 2 square root of x, and g prime of x is equal to 2x. Now, by theorem 1, ano yung sinasabi ng theorem 1 natin? Capital F prime of x is equal to f prime of g of x times g prime of x. So, yung capital F natin dito is actually h. Then, h prime of x now is equal to, okay, f prime. Ito yon, f prime of g of x. So, ipasok natin yung g of x, that is 1 over 2 times the square root of x squared plus 1. Times our g prime of x is equal to 2x. Therefore, we have, okay, times lang natin to dito sa loob, kaya magka-cancel yung 2. So, we have x over the square root of x squared plus 1. So, that is now h prime of x. Now, let's evaluate the integral of x over square root of x squared plus 1 dx. So, for our solution, note that yung derivative ng square root of x squared plus 1, yun yung sa example 1 natin kanina, is just equal to x over the square root of x squared plus 1. And since we know na ang differentiation at integration are inverse processes, then, given that h of x is equal to the square root of x squared plus 1 and h prime of x is equal to x over square root of x squared plus 1, this implies that the integral of this now, okay, yung integral nito, kasi inverse processes is actually square root of x squared plus 1 plus c. Now, h of x is equal to f circle g of x, and f of x is equal to square root of x, and g of x is equal to x squared plus 1 from our previous example. So, since yung x over square root of x squared plus 1 natin is actually galing lang siya dito, di ba, na sinimplify natin, ano ba to? This is just f prime of g of x, and this is now g prime of x. Galing dun sa example natin kanina. Therefore, pwede nating ilagay na integral of f prime of g of x times g prime of x dx. And we know that by theorem 1, eto yung ating formula. Then, etong part na to is actually equal to this part. But in this case, di ba, h ang ginamit nating variable. So, I can say that this is equal to the integral of h prime of x dx. Pero ano nga ba yung integral ng isang derivative? That is just the function itself. So, h of x plus c. Therefore, the integral of x over square root of x squared plus 1 dx is just equal to the square root of x squared plus 1 plus c. By inspection, we can see that it is easy to deal with integrands such as yung example number 2 natin. Kasi nga, derivative of the composition of two functions lang siya. We now generalize this observation using this theorem. This is the theorem for the chain rule for anti-differentiation. We let g be a differentiable function and its range to be on the interval I. Suppose that f is a function defined on I and that capital F is the derivative of f on I, then the integral of f of g of x times g prime of x dx is equal to capital F of g of x plus c. To illustrate that, let's look at this example. Let's evaluate the integral of 2x times the square root of x squared plus 1. To use chain rule for anti-differentiation, dapat yung integrand natin, same siya doon sa theorem. So observe that h of x is equal to the square root of x squared plus 1, which is f circle g of x, where f of x is equal to square root of x, and g of x is equal to x squared plus 1. Note that the antiderivative of f is equal to x raised to 3 halves over 3 halves, or that is 2/3 times square root of x cubed, and g prime of x is equal to 2x. Then by theorem 2, which is this formula, the integral of 2x times square root of x squared plus 1 dx is equal to, okay, sineparate natin itong square root of x squared plus 1 and 2x. Why? Para maging kamukha niya ito. Kasi g prime of x is 2x and f circle g of x is square root of x squared plus 1. So since kamukha na niya ito, then pwede na nating gamitin yung ating theorem number 2. So that is now f circle g of x is square root of x squared plus 1. The antiderivative of x is equal to 2/3 square root of x cubed, and g prime of x is equal to 2x. So we now have antiderivative of f of x at g of x, so that is 2/3 times the square root of, ipasok natin yung g, x squared plus 1 cubed plus c. Or that is now 2/3 times x squared plus 1 raised to 3 halves plus c. Let's evaluate the integral of sine 2x plus 2 dx. So for our solution, observe that h of x is equal to sine of 2x plus 2. So that is f circle g of x, where f of x is equal to sine x, and g of x is equal to 2x plus 2. Note that the antiderivative of f is negative cosine x, and g prime of x is equal to 2. So by theorem 2, okay, kailangan ganito ulit yung maging itsura niya. So integral of sine 2x plus 2 dx is equal to the integral of sine of 2x plus 2 times, so eto yon. Yung g of x naman natin is 2x. Pero wala kasi tayong 2x dito. Eto lang yung meron tayo. So what will we do? Mag-multiply tayo ng 1. Okay? Yung equivalent niya na 1, which is 2 times 1 half. Para magkaroon tayo ng 2 dx. Okay? So ngayon, ang itsura na niya, meron na tayong f circle g of x Tapos, meron na tayong g prime of x. Ngayon, may sobrang 1/2. Saan pupunta yan? Ilalabas natin siya doon. So, that becomes 1/2 times the integral of sine 2x plus 2 times 2 dx. So, etong part na to ngayon, kamukha na niya yung ating theorem. And since kamukha na niya, magiging result na ay antiderivative of f g of x plus c. But we know that the antiderivative of f is negative cosine x. So we have 1/2 times negative cosine of 2x plus 2 plus c. Or that is negative 1/2 cosine of 2x plus 2 plus c. So dito sa example na to, kung hindi natin mapalabas yung isang number, pwede tayong mag-multiply ng equivalent niya na 1. However, note that number lang yung pwede nating i-multiply. Hindi tayo pwedeng mag-multiply ng variable. Like for example, x over x. Hindi yun pwede. Number lang. 2 over 2, mga ganun. So yung example number 3 and 4 natin follows strictly the definition of chain rule for antiderivatives. This requires pattern recognition. Note that dapat correct yung f of x mo at g of x mo for this method to work. Luckily, meron tayong way to integrate easier. And this is called the integration by substitution. We first determine our f of x, then let u be equal to gx, and du is equal to g prime of x dx. Integration by substitution is also known as the u-du method, since u is used to change the variable and du is its derivative. Then, yung formula natin kanina using theorem number 2 can be simplified as integral of f of u du equals antiderivative of f of u plus c. Now, to illustrate this, balikan natin yung example number 3 natin kanina and evaluate this using our u-du or the integration by substitution. So, for our solution, syempre ang f of x natin dyan is square root of x. Then, u is equal to x squared plus 1 and the derivative of u is equal to 2x dx. Therefore, the integral of 2x times the square root of x squared plus 1 dx is equal to the square root of x squared plus 1 times 2x dx. But what is x squared plus 1? That is just u. And 2x dx is just du. So we have the integral of the square root of u du. Since meron na tayong formula na ganito, then we now have the integral of square root of u du is equal to u raised to 3 halves over 3 halves plus c, or that is 2 over 3 square root of u cubed plus c. But our u is equal to x squared plus 1. So, papalitan natin yan. We have 2/3 times the square root of x squared plus 1 cubed plus c. Or that is 2/3 times x squared plus 1 raised to 3 halves plus c. So, same to dun sa nakuha natin kanina sa first na method. Balikan din natin yung ating example number 4 and evaluate this using the u-du method. So, ang f of x natin dito is sin x. Ang u natin is 2x plus 2 and du is equal to 2x. So, the integral of sin 2x plus 2 dx is equal to sin of 2x plus 2 times, okay, nagdagdag tayo ng 1. So, that is 2 times 1/2 dx. Okay. Then, i-release natin yung 1. So, we have 1/2 times the integral of sin 2x plus 2 times 2 dx. By substituting, we have 1/2 times the integral of sin u du. And we know that the integral of sin u is negative cosine u. So, we have 1/2 times negative cosine u plus c. Or that is 1/2 times negative cosine of, ibalik natin yung value ng u, which is 2x plus 2. So, we have 2x plus 2. So, we have 1/2 times negative cosine of 2x plus 2 plus c. or that is negative 1/2 cosine of 2x plus 2 plus c. Now, let's evaluate the integral of ln x squared over x dx. So, ang ating f of x dito ay x. Ang u natin is ln x. And du natin is 1 over x dx. So, the integral of ln x squared over x dx is equal to the integral of ln x squared times 1 over x dx. And this is just u, and this is du. So we have integral of u squared du. Or that is now u cubed over 3 plus c. By substituting u, we have ln x cubed over 3 plus c. Now let's evaluate the integral of e raised to x sine of e raised to x plus 1 dx. Our f of x here is sine x, and we let u be equal to e raised to x plus 1, and the derivative of u now is e raised to x dx. So the integral of e raised to x sine of e raised to x plus 1 dx is equal to the integral of sine of e raised to x plus 1 times e raised to x dx. So that is integral of sine u du, which is just equal to the negative cosine of u plus c. And substituting u now, we have negative cosine of e raised to x plus 1 plus c. Now, let's evaluate the integral from 0 to 4 of the square root of 2x plus 1 dx. So, in this case naman, meron na siyang values. So, definite integral. For our solution, same pa rin nung kanina, we let f of x be equal to the square root of x and u be equal to 2x plus 1 with the derivative du equals 2 dx. So, the integral from 0 to 4 of the square root of 2x plus 1 dx is just equal to the square root of 2x plus 1 times, since wala tayong 2, magdagdag tayo ng equivalent niya na 1. So, we have 2 times 1/2 dx, or that is now 1/2. Okay, ilalabas natin to doon. Then, square root of, this is u, and then 2 dx is du. So, 1/2 of the integral from 0 to 4 of square root of u du. And we know that the integral of square root of u is just equal to u raised to 3/2 over 3/2 times, syempre, yung 1/2 natin, evaluated from 0 to 4. Or that is 1/2 times 2/3 of u raised to 3/2 evaluated from 0 to 4. Or that is, okay, magka-cancel to, u raised to 3/2 over 3 evaluated from 0 to 4. So, since u is equal to 2x plus 1, then magiging 2x plus 1 raised to 3/2 over 3 evaluated from 0 to 4. Using the fundamental theorem of calculus 2, now pwede na nating evaluate ngayon yung ating antiderivative from 0 to 4. So that is 2 times 4 plus 1 raised to 3/2 over 3 minus 2 times 0 plus 1 raised to 3/2 over 3. You can verify that that is 9 minus 1/3, or that is 26 over 3. So, we also have an alternative solution for that by changing our lower and upper limit. Yung mga limits natin sa x, pwede nating palitan ng mga limits sa u. So, how is that? So, for our alternative solution, we have the definite integral from 0 to 4 of the square root of 2x plus 1 dx is equal to the definite integral from 0 to 4 of 2x plus 1 times 2 times 1/2 dx. Ngayon, ito yung sinasabi ko. Yung lower limit kasi natin is 0. Yung upper limit is 4. But we know that our u is equal to 2x plus 1. Okay? From there, pwede natin gawing yung lower limit ng u is equal to 2 times lower limit ng x natin, which is 0 plus 1. So that is 2 times 0 plus 1, or that is now 1. So this is now the new lower limit. Yung upper limit naman natin originally is 4. So, using u equals 2x plus 1, we have 2 times the upper limit plus 1. So, we have 2 times 4 plus 1. So, that is now 9. So, that is now the new upper limit. So, ngayon, since alam na natin that this is now u and this is du, so that is now square root of u du, yung 1/2 nandito na siya, then yung upper and lower limit natin mag-change from 0 to 1 and then yung 4 naging 9. So that is now 1/2 times u raised to 3 halves over 3 halves evaluated now from 1 to 9. Or that is u raised to 3 halves over 3 evaluated now from 1 to 9. So evaluating, we have 9 raised to 3 halves over 3 minus 1 raised to 3 halves over 3. Or that is now 9 minus 13 or 26 over 3. Now using that method, let's evaluate the integral from 1 to 2 of 1 over 3 minus 5x squared. So for our solution, syempre ang f of x natin is 1 over x. Ang u natin is 3 minus 5x. At ang kanyang derivative is negative 5 dx. So, the integral from 1 over 2 of 1 over 3 minus 5x squared dx is equal now to 1 over 3 minus 5x squared times negative 5 times 1 over negative 5 dx. So, ito, ilalabas natin doon. And then, changing our limits, so we have the lower limit now is equal to 3 minus 5 times 1, or that is negative 2. And the lower limit now is 3 minus 5 times 2, or negative 7. So, we now have negative 1 over 2 times the integral from negative 2 to negative 7 of 1 over u squared du. So, pwede nating pagbaliktarin yan, pero magiging negative na to. That becomes 1/5, so positive na siya, times the integral from negative 7 to negative 2 of 1 over u squared du. Or that is equal to 1/5 times the integral from negative 7 to negative 2 of u of negative 2 du. Para mas madali natin siyang i-integrate. So we have u raised to negative 1 over negative 1 times 1/5 evaluated from negative 7 to negative 2. Or that is just equal to negative 1 over 5u evaluated from negative 7 to negative 2. Then, evaluating, we have negative 1 over 5 times negative 2 minus the negative of 1 over 5 times negative 7. You can verify in your calculator that that is 1 over 10 minus 1 over 35 or 1 over 14. Now, let's evaluate the integral from 0 to pi over 2 of the cosine of 2x over 3 dx. So we let f be cosine x, our u is 2x over 3, and our du is 2/3 of dx. So we now have the integral from 0 to pi over 2 of cosine 2x over 3 dx is equal to, the integral from 0 to pi over 2 of cosine 2x over 3 times 2/3 times 3 halves dx. So, ilalabas natin ito dito. Our lower limit now is 2 times 0 over 3, or that is 0. And our upper limit is 2 times pi over 2 over 3. So, that is pi over 3. So, we now have 3 halves times the integral from 0 to pi over 3 of cosine u du. The integral of cosine u is equal to sine u. So, we have 3 halves times sine u evaluated from 0 to pi over 3. Evaluating now, we have 3 over 2 sine of pi over 3 minus 3 over 2 sine of 0. You can verify in your calculator that that is 3 square root of 3 over 4. Note that sa pag-enter sa calculator, dapat naka-rad kayo, yung radians. Let's evaluate the integral from 1 to 2 of x minus 1 times square root of 2 minus x dx. So for our solution, we let f of x be equal to square root of x. Our u is equal to 2 minus x, and du is equal to negative dx. Now, changing, we have the integral from 1 to 2 of square root of 2 minus x minus 1 times negative 1 times 1 over negative 1 dx. So ito, pwede nating ilabas doon. So we now have negative of integral from 1 to 2 of square root of u, kasi ito, this is just u, times x minus 1 du. Ang problema natin dito, meron pa rin siyang x. So, anong gagawin natin ngayon? We have to express that x in terms of u. How? Di ba alam natin, u is equal to 2 minus x. Galing dito. Ngayon, papalabasin natin yung x minus 1 na yan. If we subtract negative 1 to both sides, so u minus 1 is just u minus 1, 2 minus x minus 1 is 1 minus x. Pero ang gusto natin is x minus 1. Ngayon, if we multiply negative 1 sa buong expression, sa buong equation na yan, then we have 1 minus u equals x minus 1. Therefore, x minus 1 now can be expressed as 1 minus u. Then, yung atin namang lower limit is 2 minus 1, or that is 1, and yung upper limit natin is 2 minus 2, or that is 0. So we now have the negative of the integral from 1 to 0 of square root of u times 1 minus u du. So we now have, okay, ito kasi baliktad yung kanyang upper and lower limit. So pwede natin ngayon gawing negative ito. So we have positive na of the integral from 0 to 1 of the square root of u times 1 minus u du. Ngayon, kapag dinistribute natin ito dito sa loob, then we have the integral from 0 to 1 of the square root of u minus the square root of u cubed du. Or we have the integral from 0 to 1 of u raised to 1 half minus u raised to 3 halves du. Or pwede natin niyang paghiwalayin. Kunin muna natin yung antiderivative ng u raised to 1 half at yung antiderivative ng u raised to 3 halves. So we now have u raised to 3 halves over 3 halves evaluated from 0 to 1 minus u raised to 5 halves over 5 halves evaluated from 0 to 1. Or that is 2/3 u raised to 3 halves minus 2/5 times u raised to 5 halves. Now, evaluating, we have 2/3 times 1 raised to 3 halves minus 2/3 times 0 raised to 3 halves para dito sa ating una. Then, sa pangalawa naman, minus, ito naman, 2/5 times 1 raised to 5 halves minus 2/5 times 0 raised to 5 halves. You can verify in your calculator that that is 2/3 minus 0 minus 2/5 minus 0. Or that is 2/3 minus 2/5 or 4 over 15. Let's evaluate the integral from 0 to 1 of x times x squared minus 1 cubed dx. So we let f of x be equal to x, u be equal to x squared minus 1, and du be equal to 2x dx. Then, the integral from 0 to 1 of x times x squared minus 1 cubed dx is now equal to the integral from 0 to 1 of x squared minus 1 cubed times 2x times 1 half dx. So ngayon, ilalabas lang natin yung 1 half doon. So we have now, our lower limit now is negative 1 and our upper limit is equal to 0. So that is 1 half times the integral from negative 1 to 0 of u cubed du. Or that is now 1 half times u raised to 4 over 4 evaluated from negative 1 to 0. Simplifying, that is 1 over 8 u raised to 4 evaluated from negative 1 to 0. So evaluating, we have 1 over 8 times 0 raised to 4 minus 1 over 8 times negative 1 raised to 4, or that is 0 minus 1 over 8, or negative 1 over 8.